Here is an object of unknown density floating at rest in a fluid of known density. Because the object is completely at rest, we know that the buoyant force exerted on the object by the fluid equals the weight of the object. If the buoyant force were less than the weight, the object would be sinking in the fluid. Now that means that the mass of water displaced equals the weight of the object, which is just the mass of the object times gravity. So the weight of the displaced fluid equals the weight of the object. mg for the fluid equals mg for the object. Mass is density times volume. So the density of the fluid times the volume of the object that's submerged times g equals the density of the object times the full volume of the object times g. Because density times volume is mass. Algebraically, g cancels out on both sides, so we're left with this ratio. The volume submerged divided by the total volume of the object equals the density of the object divided by the density of the fluid. Or the fraction that's submerged which is the volume submerged divided by the total volume, equals this ratio, the density of the object to the density of the fluid, which in water means that's the specific gravity of the object. Now, in our case, you see about 1/3 of the object is above the water and 2/3 is below the water. That means that the fraction submerged is about 2/3, or that the specific gravity is about 2/3.